Back in episode 2 of this series, the subject of piers came up. In this episode, we're going to dig into the details.
Sorry about that. I told him not to use that pun.
The building right here will be on conventional concrete piers. We have 170 plus piers.
Do you know what a pier is?
Pier.
Maybe ask him.
It's a pier.
He'll explain better than I
A
can.
pier is an underground concrete column. Let's see. So our piers are as small as 2 foot in diameter, up to 5 feet in diameter, and they're going to go about 65 feet in the ground.
And what do they do?
They're going to hold up everything.
Every single aspect of it.
How do you think they dig 65 feet down in the ground?
A big drill, what we call an auger or a drill rig.
Now, are these for the piers?
So these are for the piers. So these rebar cages, the ones we have here are specifically for our tower crane foundation. So the first piers that we will put in will support the crane. That's going to do all the heavy lifting for the rest of the pier operation, all the concrete and steel structure.
So, buddy, they'll pour concrete around all this. Remember when we went to the DeLisi plant and watched them mix concrete? It gets poured around.
So we're going to drill a hole that's a little bit bigger than this. And then once that hole makes it down to bedrock, we'll go into the bedrock a little ways. And then we'll use the crane to put this inside the hole. And a concrete and a pump truck will start filling this concrete up from the bottom up.
Do you know what this explanation means? Lego! Dad, what's the Amazon password? Imagine this base plate is our building foundation. And this is our soil base.
If we lay it on our soil base, it looks supported, but that support isn't sufficient. Soils are dynamic, and although you can take steps to prevent movement, you can't stop it completely, especially with a heavy building on top. Variations in movement and loading could put strain on the foundation, and if those forces become excessive, it can become damaged.
One solution is piers that go into the bedrock. These are my piers. That's not how they do it in the real world. Think of this pan as being bedrock. And these columns are concrete with rebar. And these little feet at the bottom, we'll talk about them later.
Now, if the soil shifts under the foundation, it's still held up by these super strong piers. Our model has 12 piers, but this project has 184 piers.
So for our piers, we drill a hole, and then what we do is we go find bedrock, and then we have to put our piers a little bit further into bedrock. Our engineer tells us how far we have to go into bedrock. So while we're drilling the hole, we have been finding groundwater at about 20-25 feet and a bunch of river sand in this area. So in order to not let the hole collapse on itself, because if there's a bunch of water and a bunch of sand, if we pull the auger out, that whole thing could collapse and create a big void. So the tanks that you saw out there, what we do is we actually, while we're drilling, we fill the hole with water while we drill. And the water and the pressure of the water keeps the sides of the hole intact. And so then we fly in our rebar cages, those metal cages that we saw that had all the hoops and all the things on them. And then when we put our concrete pump hose in, the concrete fills up from the bottom and it pushes the water out the top, and we use a pump to suck that water back into those tanks so we can use it again.
I see. So that's the purpose.
And that is the purpose.
Let's get a closer look at some of these things.
These are the water tanks that the water gets pumped in and out of. This is the pump to transfer the water. This is a rebar cage, which will give the pier strength, especially under tension loads. And this is a rebar cage getting moved by the tower crane and getting lowered into the hole. Check out the last episode on the tower crane if you missed it. And the concrete goes from the delivery truck to the pump truck through this pipe and into the hole.
The holes are put in with a drill, a really big drill.
That you'll see out here, we've got the auger bits that are kind of like this big bit that's sitting on its side right here, and then like this piece of pipe that you see on the ground right here is a clean out bucket. So essentially what they do is they'll drill the hole first with that auger bit, pull all the dirt out, go all the way down to their socket depth. Once they've got that, then they send this clean out bucket, the pipe down, and it's got a little door. You spin it one way and it opens it, you spin it the other way and it closes it. So what that does is it basically cleans out everything that's settled down to the bottom of the hole so that you have a nice clean bottom of your hole.
Here is some of that equipment in action. Let's talk about those rebar cages.
So basically, whenever we drill a pier, you have a set depth of where they have estimated where the rock's going to be. So on our job site, that estimation from basically our subgrade elevation is 50 foot. So what they've done is all of our pier cages, so from that 50 foot you have a socket depth. So from where you hit rock, you have a depth that you have to drill beyond that rock, and on the hole that they're doing right now, it's 3 foot. So right now, this number is it's a guesstimate. We don't know exactly how deep the rock is until we drill the hole. So essentially, once they hit rock, we get what the depth of rock is, and in this case, it was actually 48 foot. So what they're doing out there is they're cutting a little bit of excess rebar off of the cage so that it fits in the hole in our top of piers at the right elevation. So likewise, if you go over the 50 foot, then they're having to splice bars onto the rebar cage because they've already tied them up, accounting for that 50 foot depth.
Metal rebar can rust, so they want to make sure that it's totally encased in concrete. They use some special spacers to do that.
That whistle you hear means the crane is moving a load.
Some of the things that you'll see on the pier cage, you see the wheels that are on the side?
I did, yeah.
That's so whenever they put the pier cage in the middle, you don't want your rebar all the way up against the hole.
So spacer.
So it spaces it off the sides so that when you get concrete fully around on those doors. If it gets up close to the edge of the wall, of the wall of the pier, then you introduce the opportunity for it to rust and decrease foundation. Another thing that you'll see them do once they get it over, kind of over there by the hole, there's a guy over here that's got these white cylinder thumbs, and you see they put those on the bottom arms of that pier cage. What that does is it just holds it off the bottom. We have a 4-inch cover requirement on the bottom of the pier as well, so that effectively gets around the suits. Comes basically to the back of the ground, so it's just sitting right there.
Okay. And those are what are those made out of? Just a heavy plastic. And then this part of the rebar that's exposed.
Yeah, so whenever they come and dig their footings, their footing will tie around that rebar so that it keeps stacking up.
Not all 184 piers are the same. They can vary in diameter and in other ways.
These piers are for our elevator shaft. So whenever we build the building and start doing all of our foundation work on top of our piers, our elevator pits go down 5 foot below the actual finished floor elevation. So that's why whenever you look down into the hole, you might not actually see the rebar cage that they just put in there because it's still down to where the foundation elevation is. Yeah. The other one is closer up to our finished floor elevation.
Here you can see the rebar in place, the water level, and the pipe ready to pump in concrete.
And this hose pumps out water as the concrete flows in.
Samples are taken from all the concrete poured. These will be stored, cured, and tested back in a lab to make sure that it meets or exceeds all strength specifications.
These trucks hold 10 yards of concrete.
And each pier takes 2 to 3 trucks. When you order concrete, you specify how much you want in yards. Yards is really short for cubic yards, which is a volume measurement. 1 yard of concrete would fill up a cube that measures 1 yard on each side.
If you want to learn more about concrete, check out our other videos.
All of these piers have to get tied into the rest of the building structure.
Ours are in a square formation, but then we have these ones that are over here that are in a circle formation. So those are going to be a cylindrical column on the outside of the building right there, where this one will be a square column. So the pier cap, like I was talking about, you can see the angled bars underneath that look like they have some concrete on them. Those are that top of that pier with those bends on them, and then they tie this pier cage or this pier cap cage around it that basically gives it so it doesn't come apart. So you guys might have learned this at OSU, but concrete's very good at compression, but it's not so great in tension. So that's why we add the rebar to the foundation. So each place that you see the square boxes are pier caps. So that basically caps off the pier. And from there you have a column that'll come up. Everywhere in between the pier caps is what you would call a grade beam. And that's basically just a foundation beam that spans from pier to pier on the perimeter of the building.
So all of these individual rebars sticking up.
So those ones, whenever we go to pour our slab on grade, they'll actually get bent over, and that's what ties our slab on grade into that grade beam that's right there.
All of the completed piers are underground, so from the road, it may not look like the building is progressing. But even though you can't see them, and later, when the building is finished, most of us will never know that they're there. They are a super important part of the structure. We're glad we got to see the piers go in and better understand how buildings are put together.
As always, thanks Manhattan Construction. See you on the next phase of this adventure. So I don't have to say anything.
This is going to be some footage for...
Look at my shirt.